Hey, good afternoon, everybody. This is Rahul Singh with Anant. I'm very happy to invite you to Cassandra lunch number 11. This is the COVID edition of our Cassandra Data Stacks meetup that we host in Chicago and in DC. You can contact me if you'd like on GitHub. I have a Twitter account. I don't really use it. Or you can reach out to me at rahul@anant.us. My co-organizer is Akwi. Akwi is also available at akwi@anant.us. We are looking for co-organizers. It's a really fun job. You get to find other people. You get to find sponsors. If you want, just reach out, contact us. We're a very inclusive community. We believe in diversity from all backgrounds, race, gender, sexual orientation, religion. And I would love to have speakers from those underrepresented communities come and speak here. We're part of a bigger group called Data Community DC. Data Community DC is a nonprofit in the DC area, which covers actually eight different communities. Cassandra is just one of the groups we're incubating there. We cover different topics related to Cassandra, data stacks, and today we're going to talk about different types of Cassandra that are available today. Normally we have announcements or a bit of networking where you get up and you talk to somebody you haven't met before, but although we can't do that physically, if somebody's new to the group, we invite them to introduce themselves today. It looks like we're all regular attendees here. During the topic, if you have something to contribute, just raise your hand with Zoom and or just ask a question in chat. And if you're polite, you can also just go ahead and ask the question. We're not muting everybody here. This is a community. And it's an opportunity for you to share what you know. DataStax is a partner for this meetup. And recently, up until recently, would be sponsoring the pizza and the soda. And nowadays they're partnering with us to broadcast this or different talks about Cassandra that we're putting together onto their platform. GW University is a great partner as well. They give us a lot of amazing event space in DC. And in Chicago, we have Wavical Data Solutions that has given us their office to use in the West Loop. And then Eastern Foundry also is it's a co-working space for government contractors, very specialized. They give us an amazing space in Roslyn. We have some institutional sponsors for the nonprofit. If you're interested, please reach out. Anybody have any announcements? So we have an announcement on behalf of DataStax. They're putting together a workshop on Cassandra and Kubernetes. It's actually just cloud native with Cassandra. I'm going to bring up that link momentarily. So it's starting, this thing has been going on for a while, but all the videos are available, and I believe some of the attendees here on this meetup have been attending. Anyone here want to comment on this workshop, how it's going for them? Yeah, go ahead, TJ.
Yeah, work was pretty cool. Unfortunately, I wasn't able to attend last week's just because I was in the process of moving. But it kind of goes through the, the basics of getting set up. I know they're also kind of showing you Astra, which is like their Cassandra as a cloud platform. But I enjoy it. They also have like weekly homework assignments where if you turn those in time, you kind of get into a raffle to earn various prizes, gift cards. So it keeps keeps you very engaged, quite competitive. And obviously at the end of this 8 weeks, they're also going to give you a voucher to take a free certification for Cassandra. So yeah, I definitely think it's worth your time.
Yep. Yeah, I'm actually waiting for the last one, which is deploying Cassandra with Kubernetes. Curious to see how they make it so you can do it in 2 hours. All right. Welcome again every week, same time, same place on Wednesdays for our weekly calls. And I just mentioned the DataStax workshops. All right. Before we begin, does anybody have any Cassandra questions that they're having issues with? Maybe we can talk about it before getting into the Cassandra variants. All right, cool. All righty. So Cassandra, has been around for a while, and there's more than Cassandra in terms of the technology that meets the needs of the CQL protocol, which is the protocol to communicate with a Cassandra cluster. And these days, there's Apache Cassandra, which is the, as I say, the original gangster, the OG. DataStax is the next most, I think this is a little old one. Because DDAX is no longer relevant. So DataStax Enterprise obviously is the big commercial vendor for a commercial version of Apache Cassandra, although it's not just Cassandra, it has Spark, Solar, DSE Graph. There's also used to be something called DDAC. Now it's basically Apache Cassandra that DataStax supports, and essentially it's nothing different than Apache. It's a way to get support for Apache Cassandra. Elasandra, which we've covered before, in which Elasticsearch is used as a secondary index. There's SkillDB, which is one of the first C++ based Cassandra variants. There's Yugabyte. And I'm not going to get into the managed services because, well, they're basically these things being run by somebody for you. But there are two other variants of Cassandra, which are not actually based on Cassandra, but they act like Cassandra. So architecturally, when a developer is using any of these tools, Skilla, Yugabyte, Cassandra, DataStax, CosmosDB, or Amazon Keyspaces for Apache Cassandra, their code technically will work on them as long as they're using CQL. The drivers will work. Everything should work. It's as if you were using MySQL and you decided you want to use MariaDB, but because they use the same protocol, it's essentially the same database. Or Postgres now has different databases that allow you to connect using the Postgres protocol, including Yugabyte. Yugabyte has a way to connect to Yugabyte using Postgres. Okay, and that's just a query layer. Under the hood, Cosmos and Keyspaces, they could be implemented by a completely different technology, and it's being scaled in a completely different way. But to the end user, they're just getting a scalable platform. So just having this evidence that Microsoft, Amazon have invested in services that are Cassandra compliant. 2 other companies have made a Cassandra compliant database that's distributed, that is also open source. And then there are other companies that are building out like Ivan and Astra from DataStax and InstaCluster that are managing it. It's a signal for me that Cassandra has become a part of the infrastructure in distributed technologies. So at this point, there's competitors vying for developer attention in saying, oh, well, we have a faster Cassandra, or we have a faster, in this case, Skilla actually claims to be compatible with DynamoDB. And then actually DataStax has put out something called DynamoDB Proxy, which runs on top of Cassandra. So, DynamoDB is one of the major competitors to Cassandra because Cassandra was built out of the Dynamo paper. And a lot of people have this conception that Dynamo and Cassandra are the same, but Cassandra has forked so many times away from the original design of Dynamo that it doesn't resemble it at all. But people that are using people that are using DynamoDB, Skilla and Cassandra and DataStax are appealing options because they're open source or they can be hosted away from Amazon, right? That's the thing, that if you're using Amazon's DynamoDB, the code that is accessing the DynamoDB protocol, it can't work anywhere else. So that's why Skilla and DataStax have here, Dynamo. There we go. This has a little architecture view as well. So let's say if you're using Dynamo on Amazon, using the DynamoDB proxy, it will basically mirror the data from Dynamo to Cassandra, and then you can use, again, the Dynamo driver to connect to the proxy for DynamoDB. So that's another way that people are trying to move away from DynamoDB is by using, let's say, Cassandra or DataStax with this proxy, or SkillDB claims that you can talk directly to it. Yugabyte is another competitor, which is actually different from Skilla. Skilla claims to be primarily a Cassandra in-place replacement. And they're compatible not only with CQL, but also with the node tool protocol. So the same node tool commands that can work on a Cassandra cluster, for the most part, will work on a SkillDB cluster. Yugabyte only claims to be compatible at the query layer. Their underlying storage is different. They're doing it in a different way. And because their focus was not to mimic Cassandra, but rather to expose a distributed database with Cassandra, right? Or with Postgres, and actually they also have a Redis layer. So you can talk to Yugabyte with SQL or with what they call Cloud QL, but basically YCQL is basically Yugabyte Cassandra query. And it's got some other enhancements to it. But these are, SkillDB and Yugabyte are based on C++, and they tend to be faster. While SkillDB was built before the days of containers, it still scales on containers. Yugabyte was built for containers, for Kubernetes. In fact, that's how I found Yugabyte. And the way they do data storage is completely different from SkillDB. SkillDB actually stores data the same way that Cassandra does it. But in Yugabyte, what they do is they actually have a concept of a master and tablet server. And so it's not a pure peer-to-peer or masterless architecture. SkillDB is a masterless architecture. But what's appealing about Yugabyte is that you can have data stored in one, quote, platform, and it'll service SQL needs, it'll service Cassandra needs, and it'll service Redis needs. When I had spoken to folks at Yugabyte, they said that their goal is not necessarily to supplant Cassandra, but rather to augment people that are already using Cassandra to then start using this for some of their use cases. So it's an interesting product. They've recently also open sourced their control plane. And they've done some interesting things that's not quite there in Skilla or in DataStax yet, which is cross-cluster replication. Right now we have data center replication in Cassandra and DataStax. Why I am fascinated with SkillDB, again, it's also built in C++, but they built it using the same principles as Cassandra. In fact, they have an event-driven library in C++. They call it C star. Now, I don't know if this is by design or if it's by coincidence, but C star, the letter C and the symbol asterisk, is also used as a shorthand for Cassandra. But they use this C star event framework in C++ that they built to then build a Cassandra in C++. And I don't know if originally you could have had like a SkillDB data center and a Cassandra data center in the same cluster, because technically the protocols are all the same. I don't think that's possible now anyways. But Skilla is a formidable force in that they compete with Cassandra on primarily the speed and the storage. Because it's written in C++, it does not have garbage collection. And so it essentially can store a lot of data on one machine. Now, that may sound good, right? Not having as many machines, as many nodes. You'd think that Skilla is a better option. But at the end of the day, you're not going to be able to replace a node any faster with Skilla than with Cassandra, because the data has to be streamed from all the machines to another node. So in that case, you're back to square one, which is if you want to have the fast ability to scale in and out, especially in the day of Kubernetes, your nodes are still going to be small. That's exactly how DynamoDB scales. They have small, quote, containers of storage that scale out as needed. Another interesting thing about Skilla is that it they claim translytical architecture, in that they say that you can run Spark and Cassandra queries at the same time on the same cluster, on the same data center. And the way that they're able to do that is at the CPU level, they say, this is a pool of resources that are available to this client or this user. And this is a pool of resources available for this client or this user. So it essentially jails the compute and query capability for Skilla for one user. In Cassandra, we wouldn't do that. In Cassandra, what we do is we'd have two different data centers, one for analytical, one for transaction. You can still do that with Skilla. But I don't necessarily think about that as a translytical platform meeting the scale needs. Eventually, you're going to have different workloads and different data centers if you're going to scale out. You're going to have one data center focused on Spark. You're going to have one data center focused on Cassandra plus, just Cassandra. And that's possible without data stacks. Nobody stops. I mean, you can use Skilla on one data center and then put Skilla and then put Spark on that other data center and essentially do the same thing that DataStax allows you to do. Again, fascinating product, very fast, interesting how they've gone and deviated a little bit from the roots in Cassandra. Not everything is compatible. That is compatible in Cassandra. CosmosDB is one of the first, like apart from Skilla, was one of the first products out there that claimed to be Cassandra compliant. And similar to Yugabyte, they allow you to either access Cosmos using SQL, CQL, or MongoDB, or Gremlin, which is for graph. So very powerful concept that you can use one platform and be able to access using MongoDB, Cassandra, Tinkerpop, and then also SQL. So why would somebody use CosmosDB? Well, you know, for the same reason they would use something like Amazon Keyspaces or now DataStax Astra. They don't want to deal with the headache of managing their clusters. That's it. But with that comes a cost. So CosmosDB is very, well, relatively expensive in that they do so much in the background that it costs money. And you know, they offer a globally distributed database service, which you can build with Cassandra or with Skilla or with Yugabyte yourself, or you could just pay CosmosDB. So I think that's great that the service is out there. And eventually when people outgrow or it becomes too expensive to use CosmosDB, they may revert back to using, let's say, DataStax or Cassandra. Amazon Keyspaces used to be called Managed Cassandra Service. MCS is essentially a query layer on top of Dynamo. When they released this last December as MCS, there was a lot of conversation about, well, why is it so expensive? Well, it turns out that the pricing model for Keyspaces is very similar to the pricing model for Dynamo. It's just a little bit more expensive. So a lot of Reddit-like conversations or Y Combinator. I don't remember which news web on Y Combinator. Someplace somebody outed either from Amazon or from a conversation like, this is actually DynamoDB with a query layer based on Cassandra. Now, this feature, I look at this as just a feature for Dynamo now, is what was my major objection to DynamoDB. Because DynamoDB is a very proprietary protocol. You have to use it. Well, now if people are using Amazon Keyspaces with CQL, if they don't like it, they can move off of it. They can move off to Cosmos if they want to, or they can move off to Astra if they wanted to. So overall, Keyspaces is, again, it's another quick and get up and running with Cassandra. Perfect to start an app. Astra is basically DataStax's play into the managed Cassandra service world. They are doing a little bit more these days than just Cassandra. They happen to offer beyond Cassandra query language their own REST and GraphQL access. And the difference between, let's say, Cosmos and Amazon Keyspaces is that Amazon Keyspaces is only on Amazon. Cosmos DB is only on Azure. And at least right now, DataStax is offering the ability to do dedicated clusters on AWS or GCP. I can imagine that they're not in Azure because Cosmos DB directly competes with Astra. I'm just speculating, but I'm pretty sure that was the main reason. Or they knew that they could get this stuff done earlier, so just put it out there. We have a little bit more time, so I'll mention a couple other players in the market. So there's also InstaCluster. InstaCluster is just a managed database service company, which can also make your coffee. They do a lot of other stuff. So for, here we go. So they offer Cassandra on AWS, Azure, Google Compute, and IBM. And, you know, it's Cassandra, but you push a button and they make a cluster for you. Ivan is a direct competitor to InstaCluster. They do the same stuff, Kafka, Elasticsearch, just like, you know, InstaCluster does. And they offer this offering on different cloud platforms, including the big three, but as well as DigitalOcean. You know, we use DigitalOcean for stuff. Their interface is modern. They're a modern company. They've got some street cred with the big companies using it. But they're a small company. InstaCluster, a little bit bigger than them. But it gives people the ability to get Cassandra and other databases managed. So, you know, on one end of the spectrum, you have Cassandra. Then you have DataStax. Right? Then you have Cassandra. These are the Java variants. Then the Java-based Cassandra hosted on Ivan. The Java-based Apache Cassandra based on InstaCluster, or managed by InstaCluster. And at this point, we're at the edge of known code, right? We know this is Java-based. Or sorry, not the edge of the known code, but this is Java-based. Then we have SkillDB based on C++. Go to their website, show off their brand name, to be fair to them. It's funny, they talk about, they're really pimping out their DynamoDB compatible API. Lightweight transactions, again, they're catching up to some of the features in Cassandra, right? Change data capture was not there yet. You have Gigabyte, which also starting to do change data capture. Where do they have their website? There we go. A lot of people using Gigabyte. Quite a company. Okay. So these are based on C++. Then we have Cosmos. And we have key spaces. And Astra, which kind of falls into maybe, it's kind of somewhere between these guys and the Java Apache Cassandra managed clusters. I'll put it right here. So we got Apache, DataStax, Cassandra, Ivan, InstaCluster, DataStax, Astra. 1, 2, 3, 4, 5, 6, 7. SkillDB, Gigabyte 8, Cosmos 9, Amazon Key Spaces 10. 10 different ways to use Apache Cassandra protocol. Not really Apache Cassandra, but Apache Cassandra compatible. All right. All right, so got a bunch of cool stuff out there. Any questions about the different tools and Any specifics about any questions that anybody has? Let's see. I'll ask a question from the audience here. So Arpin, which of these, if you were to get started with an app that had to be Cassandra compatible, which one would you use first? And don't say Astra if you used it.
So my main language would be Node. And so I would be looking for Node compatible options. I've already looked into it and I built a cluster with key spaces. I hadn't actually programmatically tried it yet. I hadn't had the time, but it was pretty simple. But obviously Astra was a little bit easier to do it, but in pricing as well, because Astra has a free tier. But yeah, key spaces has a Node compatible driver you can use. I didn't look too in depth into Microsoft's Cosmos. I believe they also have a Node driver as well, but I haven't worked too much with Skilla or Gigabyte to start with them. So probably outside of something I'm already familiar with, like Apache DataStax and Astra, I'd probably start with key spaces or Cosmos just to get it in the cloud already, so I don't have to worry about managing clusters. Yeah.
Got it. Yeah, technically you shouldn't need to worry about, whether the Node.js would work on there or not. You should be able to use, so in this case, they have the Cosmos client, but if it's truly CQL compatible, you can use the DataStax driver to talk to it because it's following that protocol. That's what my understanding is. Same thing with key spaces, right? They claim to be compatible with CQL and developer tools with the ones that Cassandra has. Okay. Obi, what about you? Which one would you lean towards?
Probably Skilla, because you said that one is the most Cassandra-like to the point where you can still use node tool and stuff, and it does seem to slot pretty well in terms of the Chronos project. Some of the old commits that I've looked through, it doesn't look like they had to do all that much to change the Skilla migrator that they're working with into a Cassandra utility.
Gotcha.
So it seems like something I could get use out of without having to put in too much extra work.
Got it. Cool. Cool. TK?
I'd probably also lean towards Skilla, just because in undergrad I used a lot of C++ in a lot of my projects. So it'd be interesting to see if I could still remember, everything I learned. I didn't think it was too bad going through it, so I think that's where I'm kind of leaning.
Mm-hmm. Cool. Very cool. Well, my preference, I would say, just to kind of weigh in on this, is I look at what my goal would be, and if I'm building an app on Azure, Azure has the best place to run .NET, right? Because Microsoft makes .NET, and it may be easier to just work with .NET or with serverless functions on Azure functions and just use Cosmos. If I'm working on a system that's native to Amazon and they're using a lot of Lambda, then I might say, you know what, let's just start with key spaces. But if I'm making software that is eventually, I know for a fact that it needs to be independent of a cloud. If I go into development mode, I would probably use either Astra, InstaCluster, or Ivan to just get started, because I know it's Cassandra. I know that I could lift and shift the data model and the data to another open source Cassandra cluster, and that would work, right? It's pure Cassandra. And they can scale because they're just using one of the public clouds, all of them. Astra is using AWS and GCP. Ivan is using these clouds here. InstaCluster is on, where did it go? I thought I saw, yeah. So they're on AWS, Google, Azure, IBM Cloud, right? And even if I didn't want to be on there later, I could build out our own cluster for, or whatever the project would be. Or if it's a software that some company needs to deploy on different customers, they would have the option of either using a subscription to Astra, InstaCluster, or Ivan, or they could build up their own cluster. So that I would lean towards these to quickly get started. And there's always just doing it on Docker, right? Just making an instance in Docker and playing with it. But when you really start to develop an application and you need to be working with other people and there needs to be a real environment, it's just easier to just have somebody deal with the data layer. Now I'm looking to and I'm very excited about the Kubernetes improvements and Cassandra 4.0, where technically the layer that matters these days is just Kubernetes. So if you define the service for Cassandra properly, then you could just say, I want a scalable Cassandra cluster on anywhere that Kubernetes is running. So managed Kubernetes on Amazon, Azure, Google, or my own Kubernetes. I don't know if Ivan does Kubernetes. Nope, Ivan does not. Kubernetes is a big lift. If somebody says they do manage Kubernetes, it's a pretty big lift. Now they say they do, but this is mostly probably for, oh, this is just the operator. It's just the operator for Kubernetes. Cool. Any other questions? All right, so just to recap, we talked about different variants of Cassandra, Cassandra.Like, and Cassandra, managed Cassandra tools. There are 10 different ways to start using Cassandra today. It just depends on what you're trying to do. The same data modeling challenges that one may have in Apache Cassandra is exactly the same challenges they would have in key spaces. So using one of these providers doesn't make the application better. The data model still matters. Application scalability, how good your software is still matters. So that's something that I want to reiterate for anybody watching this video later is just because somebody's running your Cassandra cluster doesn't solve your software problems or your data model problems. All right. Well, with that, we will call it a day. Guys, have a wonderful rest of the week, and next week, same time, same place.